Hi, happy Monday, everybody. Today we're going to look at day 5 in our unit, which is on equations with special solutions. So our learning target today is I can solve an equation that does not have exactly one solution. So there's a hint as to why we call it a special equation. For now, if you want to go ahead and pause and get your notebook set up and hit play when you're ready to continue. All right, so equations with special solutions, what are they? As I mentioned in the intro, they are equations that do not have exactly one solution. Most of our equations that we've worked with already this year always have one solution. Here's just a basic example. X plus 1 equals 5. We know that the solution is 4 because when you subtract 1 from each side, we end up with x equals 4. Or you could even think of it as, substituting a value for the variable to make the equation true, that 4 plus 1 equals 5, so x must equal 4. And that's one solution, one exact solution when you get, x equals a number. That's the answer. Here's an example of an equation that does not have exactly one solution. What I mean by that is if I think of a number like, 2, does x equal 2? Well, it says that 3 times the x value equals 3 times the x value. And I get 6 on the left, and I get 6 on the right. So that means that the x would equal 2. Was that just a lucky guess that I thought 2 was the answer there? Not quite so much. Really, I could have picked any number. I could use 5. Okay, if I replace x as 5 in both of those, now it says that 15 equals 15. I mean, think of it. If I take 3 times a number on one side and 3 times the exact same number on the other side, won't I always get a true statement? It makes the equation true. So in this case, x could really be anything. That's what makes that type of equation a special equation, or an equation with a special solution. So here are the two different types of equations that we'll encounter. There are equations that have no solution, and that's the ones that have no value that will make the equation true. In other words, it's kind of like a trick equation. There's no possible value for x that'll ever make the equation true. For example, what if I said x equals x plus 10? Can you think of a value for x that would make that true? Is it possible to take a number like, 5, and say that that's going to equal 5 plus 10 more? There's no way that'll ever be true, because on one side, it will always be 10 bigger than the other side. The other type of equation are the ones that have all real numbers as solutions. In other words, any real number will make the equation true. And that's exactly like we saw on that previous example that said 3x equals 3x. Because 3 times a number will equal 3 times that exact same number. Any value for x will make that equation balance out. So we're looking at, for answers today, either no solution, if there is no value for x, that will make it true, and all real numbers, if any real number will make the equation true as a solution. And in both cases, there's not one exact answer. Let's look at some examples. Example number 1, x plus 5 equals x plus 5. What I would do in an equation like this is just start with, just like we did multi-step equations, try to get the variables to the same side. Now, if I want to try to move this positive x to the other side so I can combine it with the other x, I have to make sure that I'm using those inverse operations. So I have to take x away from each side. Keeping in mind that x is really the same as 1x, each of those subtractions represents 1x minus 1x. And 1x minus 1x is really just 0. But it also happened on the other side that 1x minus 1x is 0. And I'm left with 0 plus 5 on the left and 0 plus 5 on the right. Uh-oh, where'd the x go? Where's the variable? Well, it actually canceled out on both sides. When this happens, that's like a light bulb goes off. I don't know if I can draw a good light bulb. Okay, like a light bulb that says something's going on. Okay, this isn't quite right. I can't have an equation without x in it. Well, you actually can, and it's one of our special equations. And in this case, when we get 5 equals 5, that will be true. So any value for x will make an equation true like this. So the way that we answer it is we say all real numbers, which represents that all real numbers or any real number is a solution. We don't get an answer like x equals 5 or x equals 12. It's just x can be anything. X equals 1, x equals 2, x equals 3. Any real number you can think of is a possible value for x. All right, let's look at example 2. 4x minus 9 equals 4x plus 5. Let's start the same way. Treat it like a multi-step equation. And we want to try to move the variable term over on the other side to combine with the other variable term. To move a positive 4x, I'm going to subtract 4x. I have to do the same thing on the other side, though, to keep it balanced. And when I subtract 4x minus 4x, it's going to equal 0, leaving me with negative 9 on the left-hand side. When I subtract on the right-hand side, 4x minus 4x also equals 0, leaving me with positive 5. Now, does negative 9 equal 5? I don't think so. I would consider this to be a false statement, which tells me then that x can't be anything. In the last example, I think we got 5 equals 5, which is always true. So all real numbers are solutions. But here we're saying there's no way that those two numbers can be equal to each other. So there's no possible value for x that can make this equation balanced or make it true. So this is an example where we would say no solutions. Let's take a look at example 3. We're starting to get a little bit more involved here. We have more of our multi-step equation happening, keeping in mind what we now know about special equations. In example 3, I see my equal sign, and I see that I have a little bit of work to do on both sides. On the left-hand side, I need to distribute the 2. I have to take 2 times 2x, which is 4x, and then I have to take 2 times negative 3, which would be a negative 6. So it would represent 4x minus 6. On the right-hand side, I notice that I have 2 terms with the same variable. Therefore, they're like terms. When I add those together, 3x plus 1x, I get 4x. And I bring down the minus 6 along with it. And now it's just like the previous examples. I want to try to get my 4x to the other side so I can combine my like terms, my variable terms. Because it's a positive 4x, I want to take it away from each side. Now when I do that, I end up canceling out because it equals 0. 4x minus 4x is 0, and 0 minus 6 is negative 6. And the same thing happens on the other side. 0 minus 6 is negative 6. Now notice again here that I do actually make a true statement, that negative 6 does equal itself, so I would answer this by saying all real numbers. Any value for x would actually make that equation true. And example 4. If you're feeling up to it, you could pause the video and try this one on your own, and then play to check to see how you did. On the left-hand side of my equation, I need to distribute. 3 times 4x, that's 12x. 3 times negative 5, because remember it's like 3 times negative 5, that's minus or negative 15. On the right-hand side, we have to also distribute. We do 2 times 6x, which is 12x, and 2 times negative 8, which would be, let's see, negative 16. So 12x minus 15 equals 12x minus 16. I want to get my variables together, so I need to move my 12x to the other side. And I would accomplish that by subtracting 12x from each side. The only problem is 12x subtract 12x is 0, and that happens on both sides, leaving me with negative 15 on the left, because remember it was 0 minus 15. And on the right side, 0 minus 16 is negative 16. My variables canceled out, and I'm left with an equation. Is this true or is this false? And hopefully you realize right away those are not balanced. It is not a true equation that one number equals the other. And because this is false, we should say no solution. So that's our lesson on equations with special solutions. It all boils down to when the variables cancel out and you just have two numbers left, you have to determine if they're the same or if they're different. When they're the same, it makes the equation true. When they're different, like this one, it makes the equation false. And that determines how we answer. All right, you should now be ready to try the Day 5A assignment. I believe it's 5 questions. Please put your work in your notebook so you have a few extra examples, and you also have your notes handy. So if you have any questions, you can go back and reference the notes. Please try to have this finished before our next class. Have a good day.